Hey guys, today we're going to be looking at neutralization reactions, which is going to be a bit of a review because they are just a special type of double replacement reaction that we looked at in Unit 4. So this first one we're going to look at is a reaction between an acid and a base. All neutralization reactions are between acids and bases, and they make water and a salt. And salt doesn't always mean NaCl, that's a specific type of salt, that is table salt. It is just an ionic compound. So if you look at this reaction down here, we start off with an acid and a base. The acid is H2SO4, which we know because it starts with hydrogen, and acids start with hydrogen. So go ahead and label that. And then KOH over there next to it is a base, because bases end in OH or hydroxide. And anytime acids and bases react, it's a double replacement reaction, which means that the first two elements, the cations, are going to switch places. So here, the cations are hydrogen and potassium. Those are going to switch places. Potassium is going to end up with SO4, which you see on the right-hand side, and hydrogen is going to end up with OH. And whenever you put hydrogen with OH, you end up with H2O, which is simply water. So the H2O over there is water, which leaves K2SO4 as your salt. And sometimes salts will be dissolved, but sometimes they'll form precipitate. So we're going to look at that down below in some more notes. Once again, how can you tell it's neutralization? A neutralization reaction has an acid and a base, and it makes a salt plus water. So the skill you actually have to be able to do today is predict products given an acid and a base and knowing that they're going to form a neutralization reaction. So you can follow these steps that I've outlined here for you, or you can just watch as I do it on this example here. This example is phosphoric acid and calcium hydroxide reacting to form something new. And we know that it's double replacement. So we're going to switch places with the hydrogen and the calcium. I'm going to show that here. Swapping hydrogen and calcium. That means calcium is going to end up with PO4, and hydrogen is going to end up with OH. Now, anytime that you do a double replacement and you write down some cations and some anions, you have to check their charges to balance them. Remember, you can find the charges on top of the periodic table based on their number of valence electrons. Calcium has a charge of +2, and phosphate, which you can go look up on your polyatomic ions list, has a charge of -3. If you don't know how to find these charges, email me and I'll refer you to a previous video over how to do that. And if those charges don't match, you have to flip them down, so you end up with Ca3 PO4 2. But anytime you have multiples of a polyatomic ion, you have to put it in parentheses. So you have to put PO4 in parentheses with a little 2. And then HOH is just water. You can rewrite it as H2O if you like, or you can leave it as HOH. Now typically when you write an equation, you should balance it. For the sake of the length of this video, I'm not going to do that here, but if you would like to know how to do that, once again, email and I can refer you to a different video. Assuming you had already balanced it, the last thing you need to do is check to see if the salt is soluble. In our previous unit, we checked both products, but water is the solvent, it's the universal solvent. It dissolves the other thing, so we don't have to check it. We leave it alone. We're going to have to check this Ca3PO4 2. And for that, you're going to need a solubility chart. This is the recommended solubility chart that we've been using in class. It's located down in the class materials in Google Classroom if you can't find it. But what we're going to have to do is find this compound on the solubility chart. To do that, you always look at the anion, which is the last part of your compound. So we're going to look at PO4 and see if PO4 is soluble or not. And we go look at that on the chart. PO4 is right here in the insoluble section. Insoluble means it does not dissolve, unless it's with one of these things over here listed in the exceptions. The exceptions are NH4 and alkali metals. So you need to know if calcium is NH4 or an alkali metal. And calcium falls in the alkaline earth metals group, so it is not NH4, it's not an alkali metal, it's not an exception, which means PO4 remains insoluble. Insoluble means it doesn't dissolve, so it forms a precipitate. And if it forms a precipitate, you can do one of two things. You can either write a little S to represent solid, because it's going to make a solid, or you can write a little down arrow, which means it falls out of the solution and forms a precipitate. Either one. The only thing that's different from double replacement reactions that we did in Unit 4 is that if it is not a precipitate, if it stays dissolved, you don't just leave it alone, you put a little AQ for aqueous. That's the only new thing. All right, if you got any questions, please email and ask. Otherwise, you need to finish up the last 2 pages of your acid and base practice. It covers a little bit of pH and neutralization reactions and solubility rules. So everything's gonna be included on there. If you are in on-level chemistry, be sure to check the instructions on your assignment to see which questions you need to skip. All right, y'all have a good day.